So this is going to be slightly different depending on what class period you were in. But once I get past these first 3 boxes, we should be in okay shape. So if your magnesium was on something, then we'd have to do a calculation here. So for example, crucible and magnesium minus the crucible. If your magnesium was just on the scale, this would be not a calculation, just whatever. But you should have ended up with the mass of magnesium maybe about 0.1, I'll just say 1, 2, 3, 4 grams. Something like that. Magnesium and oxygen, this is after the reaction was all over. So same kind of thing. This one you definitely had either a crucible or a watch glass. Crucible and magnesium / oxygen. This was the whitish stuff minus the crucible. So something like maybe this should have been bigger, which is the problem we had first period, but maybe 0.01762 grams. Now, here's where we get into some maybe different things. So if the magnesium weighed 0.1234 grams and the magnesium and the oxygen weighed on there, ideally magnesium or oxygen particles went into the crucible from the air. So in this case, I would do 0.1762 grams, which was magnesium / oxygen, minus 0.1234 grams, which was just my magnesium, and that would tell me that my oxygen weighed 0.0. Let's see, I'm going to have a 528, I think, grams. I guess I could get out the calculator. 0.1762 minus 0.1234. 0.528. Awesome. Now, my mass ratio, I'm going to go back and label these a little more carefully. This is magnesium up at the top and oxygen down at the bottom. So my magnesium to oxygen ratio in mass is, for every 0.1234 grams of magnesium, there is 0.0528 grams of oxygen. But we want a more simplified ratio. So I can say for every 0 blank grams of magnesium, there is, this is the smaller one, so it's usually easier to make this one be equal to 1. So in this spot here, I'm going to be dividing by 0.0528, because that number divided by itself will be 1, which means that over here I need to divide by 0.0528. Okay, and that's definitely going to be helpful to do this. So 0.134 divided by 0.0528 equals 2.33 grams of oxygen, of magnesium. There is 1 gram of oxygen. Percent magnesium by mass. This is the mass of magnesium over the mass of magnesium / oxygen. So therefore, this needs to be 0.1234 grams of magnesium over 0.1762 grams. That was the total thing of oxygen. And that would be equal to X. Make this a little smaller. Sorry. Over 100. So that's where I could cross multiply and divide. I would get an answer of 0.1234 times 100 divided by 0.1762 and get that it's about 70% magnesium. let's see, in this case we have 4 significant figures on both, so I would say 70.03%. Now, I could just subtract that from 100 to get my oxygen percentage, but I'm going to go ahead and double check it just to make sure I didn't do something wrong on the first one. So mass of oxygen over mass of the total thing, my part over total, that this is 0.0528 grams of O over 0.1762 grams of magnesium oxide, which is everything all together. This would be, equals X. This is going to be my 100. So it should be 29.97. Let's double check. 0.0528 times 100 divided by 0.1762. And yep, it is 29.97 97% oxygen. And I'm going to go ahead and just label that here. It's in the data table, but just so that we can kind of keep it clear. So that means that it's in a 70 to 30 ratio, which is about what this 2.33 to 1 would be. So those are equivalent. That's the same thing. Okay, now we need to go to moles of magnesium. So I know that 1 mole of magnesium, there is a mass of 24 point, going out my best around the periodic table, 31 grams of magnesium. That's what I know. And in this case, I am solving for moles of magnesium. And I don't have 24.31 grams. I have 0.1234 grams. So this is where I would need, I don't know what that factor is. It's something big. But if I do 24.31 divided by 0.1234, I get 197. So I'm dividing both of these by 197. Dividing both of them by 197. And 1 divided by 197 is 0.005. Let's see, again, we need 4 significant figures. Those first zeros are not. 0.5076. 5076 moles. Moles of oxygen. Same thing, I'm going to take my mass of my for every statement. 1 mole of O. There is 16.00 grams from the periodic table. I have I'm solving for moles. I have 0.0528 grams of oxygen. So again, something big here. 16 divided by 0.0528 gets me 303. I'm going to divide both of these by 303. So if I do 1 divided by 303, I get 0.00300. That would be 3300. Sorry, 4 significant figures. Particles of magnesium. I know that 1 mole of magnesium has 6.02 times 10 to the 23rd particles. I could have also said that this is 24 grams. So now I know how many moles of magnesium I have, and I know how many grams of magnesium I have. So I could use either one. I'm going to go ahead and use my 24 grams because grams was a measurement that I made. So that's less likely to be messed up. So this is 0.1234 grams. There is blank particles. 24 divided by 0.1234 is 194. So divided by 194, divided by 194. And if I do 6, let's see, does this thing do scientific notation? No. So I'm going to just make this 602 and take out 2 powers of 10, just because of this weird computer calculator. Divided by 194, and I get 3.103. 3.103 times 10 to that. Took those 2 tens out, so it's 10 times 10 to the 21st particles. I can do the same thing down here. 1 mole of oxygen is what I could do, is equal to 6.10 times 10 to the 23rd, but 1 mole of oxygen weighs 16 grams. Here is 6.02 times 10 to the 23rd particles. I had 0.0, where did it go? 528 grams. And I could do 16 divided by 0.0528, and I get 303. I guess I already knew that. 303. And that means I would divide this one by 303. I'm going to do the same trick that I did there before and take 2 tens out of here. Make this 602 times 10 to the 21st. Say 602 divided by 303 gets me 1.987 once I round it. 0.987 times 10 to the 21st particles. Okay, last two. Mole ratio. I'm going to use my moles of magnesium and my moles of oxygen. And I have, in this experiment, 0.005076 moles of magnesium. There is 0.003300 moles oxygen. I have to make this a little smaller. I want the smaller one probably to be the number 1, so that's oxygen. So I'm solving for moles of magnesium. 1 mole of oxygen, which means I am dividing both of them by 0.003300 and dividing by 0.003300. So 0.005076 divided by 0.0033 gets me an answer of 1.5 moles of magnesium for every 1 mole of oxygen. Now, we know that atoms can't come in a decimal ratio, so you might want to go ahead and double both of these and make them 2 and 3. However, if you're not sure, leaving them as 1.5 to 1 is completely fine. Now, I'm going to try to get this last one done before I run out of time. I've got 3.103 times 10 to the 21st particles of magnesium. There is 1.987 times 10 to the 21st particles of O. Make this a little smaller. I want to make them both be 1. So again, I'm going to divide them both by 1.987. And I can do 3.103 divided by 1.987. Oops, I forgot my 1. 1.98. Why is this not working? 3.103 divided by 1.987 equals, again, 1.5 particles of magnesium. There is 1 particle of oxygen. So this should make sense because we know that 1 mole of oxygen has the same number of particles as 1 mole of magnesium. So when we simplified both of them, basically, ending up with the same mole ratio